So, just to review from yesterday, we're looking at the 8.4 journal from yesterday. We're finishing up those last two problems. If you weren't here yesterday, it's okay. The notes should already be posted if you need them. Yeah. The notes for today aren't posted yet. Do you want to move like right there so you can see it? Yeah. Go behind the door where the calculators are. Open that. Okay. All right. So just to review from yesterday, what was the formula that we used like exclusively yesterday? Elise. Right. So the area of a rectangle being length times width. So A equals length times width. That's like the creme de la creme of this lesson. All right. So yesterday specifically, we were given like say the area as an actual number. And then they told us that the width was like, X. And then the length was this in terms of width. All right. So we had to write expressions from math to create those expressions. And then we used the area formula to solve for X. All right. What solving method did we predominantly use for that? So think 8.3. How do we find those zeros? Which method did we use? Factoring. Good. So factoring was the predominant method that we used yesterday. Almost any problem that I throw at you like this, they should be factorable. So that should be the method that you use. All right. Now, that was more of the easier ones. Today, we're going to look at some where they're not complicated per se, they just have a little bit more to them. All right. So let's look at example 3. So remember, if you're not, what's the first step that you should always do after you read the problem? So draw a picture essentially. Yeah. So remember, when you're doing any word problem, especially if it has anything to do with geometry, take the extra 10 seconds and draw a quick picture so you know what you're looking at. Sometimes I like to draw the picture as I'm reading the problem just so I kind of can get a better understanding of what's going on. So let's look at example 3. So a square has one side increased in length by 2 inches and an adjacent side decreased in length by 2 inches. So let's just break down that first sentence before we go any further with that. So a square, what does it mean for a square to be a square? What is a square? Elise? 4 equal sides. So I'm going to draw a shape that has 4 equal sides. So that's why we have these tick marks. So that shows that all the sides are equal. And we're going to call the side length of the square X. All right. We don't know what that side length is, but we know that it's going to be the same all the way around. Now, one side increased in length by 2 inches and an adjacent side decreased in length by 2 inches. If the resulting rectangle has an area of 60 inches, all right? So, in other words, they're taking the original side length of the square and they're adding and subtracting some stuff to it to create a rectangle. So, if both sides of the square are X, so this is X and this is X, we have to do something to create a rectangle with an area of 60 inches squared. So let's decipher the first part of what they said. So one side got increased in length by 2 inches. So one side of the square got increased in length by 2 inches. What does that mean I need to do? Add 2 to what? Or what's the value for the length? Just x. All right. So we're going to take this x and we're going to add 2 to it. So we'll have x plus 2. Now, the other part is an adjacent side decreased in length by 2 inches. So what does it mean for a side to be adjacent to another side? Nope. Opposite and adjacent are completely different things. So opposite side means it's the one directly across from it and they're congruent. What does adjacent mean? Kind of. So let me ask you guys this. With this x right here, well, would this side be the adjacent side? Or would this side be an adjacent side? The green. All right. Adjacent means it connects to the other side in question. It touches it. Because you see, it touches the other side right here at the corner. It meets it. Opposite means that they're parallel, they never touch. All right. So, that being said, all right, we're going to take this side and do what with it? So, the adjacent side decreased in length by 2 inches. So, what does that mean we have to do? Minus 2 from it. So, this side will be x minus 2. Now, what they want to know from this question is, what was the area of the original square? So, what they want to know is, what is this area? All right. So, to find that area of the square, what do we need to know first? It relates to that. But how do we find the area of a square? We need its what? The length and the width, or just that one side that all the sides are equal to. All right. How can we find it? Using the information that we're given. Elise. At some point in the process, yes. But what will be my first step? What do you think? Look at the information you're given. Where on this problem would it be beneficial, or do we have enough information to use our area formula? Elise, what do you got? Right. So we're going to use this rectangle. We're going to use this rectangle to help us find the side length of this square. Because, and we can do that because the side lengths of the rectangle are written in terms of the side lengths of the square. All right, that's what that x means. So this x is the original side length, and if you notice, both of these are written in terms of that side length. That x is the same number. So all three of these x's are the same number. All right. So in math, if you're solving a problem and you assign a variable within that problem, that variable stays the same across the board. All right. If you intend for that variable to be a different number, you need to assign a different variable. All right. That's how we distinguish that in math. So since it's all the same variable across the board, that means that variable is the exact same number. All right. So like Elise said, we're going to set up the equation x plus 2 times x minus 2, and it'd be equal to what? 60, because that's our area. So because we had enough information from the rectangle to set up an area problem, we can use that information to solve for x. We can't really use the squares information because we don't have an area. All right. If we did have an area, this would be a bit easier. We just do x times x and whatever, set equal to whatever the area is. But again, we don't have that area, so we can't do that. So what do you think my first step for solving for x would be here? We need to distribute, so FOIL or do a box method. So I'm going to do a quick box method for the x plus 2, x minus 2. So this would be x plus 2, x minus 2. X times x is x squared. 2 times x, 2x. Guys, heads up, please. All my little sleepy heads, wake up. Negative 2 times x. Negative 2 times 2. Negative 4. Now, when we end up combining like terms, what happens to our two x values? They cancel out. They'll become 0. So the only parts that we care about are the x squared and the negative 4. So this would be x squared minus 4 is equal to 60. Now, review from last unit. Does anyone remember what this is called? What type of polynomial this is called? Well, it is a binomial, but factoring wise, what type of special binomial is this? It's a what? Not perfect square, but you're close. Can't do cubic and square in the same thing. I'll give you a hint. DOS. That's the acronym. Difference of squares. Good. So this is a difference of two squares, which you can then see through how we factored it. Because we did the square root of x, square root of 4, separated 1 by a plus, 1 by a minus. All right. Now, solving purposes. What's my next step if we're solving by factoring? Good. Why are we subtracting 60 to both sides? Because we want one side equal to 0. And which value I'd subtract the 60 to? The negative 4, because we got to combine like terms. So this goes away. I get x squared minus 64 equals 0. Now, we do not need to do big X for this factoring. Why? What's special about this right here? Elise? We can square root. So in other words, it's a what? What's the name of it? We just said it. Difference of squares. So x squared is a perfect square, 64 is a perfect square, and they're being subtracted from each other. So we do have a difference of squares. So this right here is a difference of squares, meaning if we have a squared minus b squared, we factor it as a plus b, a minus b. All right. So I'm going to go ahead and take my square root of both of them to find a and b. What would my a value be? X. Square root of x squared is x. What's the square root of 64? 8. So factored, this would be x plus 8 times x minus 8 is equal to 0. So now we got everything factored. So what's my last step for solving for x? Make two different equations, solve the mini equations. So this would be x plus 8 equal to 0, x minus 8 equal to 0. We separated it into two mini equations. All right. Then we just solve them. So we subtract 8 to both sides. That goes away. X is equal to negative 8. Add 8 to both sides. That goes away. X is equal to positive 8. Now, recall what I said yesterday. Which answer is the only one that can make sense in terms of the problem? Positive 1. Why? Close. Think about measurement. Right. You can't have a negative measurement. If you were, if you were trying to measure out the amount of fencing you have, you're not going to have a negative amount of fence. All right. You have 0 and that's it. All right. It doesn't go past that. So we can toss out the negative answer, and the x value that we want is 8. So this is actually the side value of the square. Now, that is not our answer. Why is that not our answer? What the question asks us to do? Find the area of the original square. Good. So we're not done with the problem. So I'm going to come back up here to my square. And we know that both of these sides are equal to 8 because all sides of a square are congruent. So if we do 8 times 8, because length times width, what's the area of the square? 64 what? Inches squared. So my area of the square is 64 inches squared. Now, just for funsies, like review-wise, let's find the missing side lengths of the rectangle, which is very quick because we already know what x is. All right. So this is the area of the square. Now, how would I use my x value that I now know to find the side lengths of the rectangle? What would I do? Right, we plug in 8 in for both of my x's and then evaluate. So the top part, I would have 8 plus 2, which is 10. Bottom part, I have 8 minus 2, which is 6. So my two side lengths are 10 inches and 6 inches. And let me ask you guys this. Is it true that 10 times 6 gives you 60? Yes. So in other words, it matches what the area is supposed to be as well. It makes sense in terms of the problem. All right. So sometimes if like you don't trust yourself with that, if you got the right answer or not, take a minute and throw it back into the information that you're already given, like with that area of a rectangle, and check to see if you actually get the area of the rectangle correct once you find the two side lengths. And then if you are correct, use that to find the square area. So it's not anything new from yesterday. It's just, there's a little extra to the problem. So guys, you need to put your Chromebooks up, please. You don't need them right now. All right, any questions on example 3? All right, last example we're going to do. All right, so let's read the problem together. The length of a rectangle is 8 and the width is 6. So they already told us the exact dimensions of this rectangle. So if we have a rectangle, length is equal to 8, width is equal to 6. So what would the area be? So the length is 8, width is 6. What's the area? 48. There you go. So it's 48 units squared because they didn't give us a unit. Now, if each dimension, meaning the length and the width, is increased by the same amount, a new rectangle is formed with an area of 72 more than the area of the original. So let's break down what all of that just said. So if each of these dimensions, so the width and the length, is increased by the same amount, we don't know what that amount is. So what should we say that amount is worth? Like what would be that placeholder for the amount that we don't know? X. So let's say X equals the increased amount. That's the amount that we increased by. Because it's by the same amount, so we only need one variable. it forms a new rectangle. So we have a different rectangle, probably a bit bigger. Now, if I increase both of the side lengths by x from the original rectangle, so this is the original, this is the new. What would be my new width? What would be my new expression for width if I increased it by x? So if I increase the original width by x units, what would that new expression be? Well, we're not solving it just yet. How would I write that expression? Right, x plus 6. So increased just means addition. All right. So if you say increase, that just means addition. So w would be now x plus 6. And the reason I'm putting the x in the front is that it'll make a little bit more sense when we do, our boxing and everything. You don't have to, but it just makes it a little easier. What would the new expression for length be? If I add that same x amount to it. X plus 8. Good. So we don't know what this amount is. That's the question. But we do know that it's the same amount added to both. Now, they did tell us that the area is 72 more than the area of the original. So in other words, the area will be equal to what? How would I find the area of that rectangle? Right, you do 48 plus 72, which would equal 120 units squared. So this is the new area that we're shooting for, 120. All right. Yeah. Yes. Can you wait till the break? We're almost done. So now the last part of the question is it wants us to find the dimensions of the new rectangle. So first things first, we got to figure out what amount they actually increased each of those lengths by. All right. So we're going to set it up just like we've been doing. So what do you think the setup's going to be? Equals? Right. X plus 8 times x plus 6 equals 120. We're writing an equation to represent the area. Then you're going to do a quick box method to FOIL out those parentheses. So I'm just going to do a very, very quick box. You guys should be very familiar with this by now. So x plus 8, x plus 6 on the side, x squared, 8x, 6x, 48. So if I combine like terms, it would be x squared plus 14x plus 48 is equal to 120. What's your next step for solving? We can't big X just yet because we don't have a... Right. We got to subtract 120 to both sides because we need one side equal to 0 before we big X. Because if you notice, if we big X'd this expression, we get what we started with. All right. So that kind of be counterintuitive. So this would be x squared plus 14x minus 72 is equal to 0. Now we can do big X. All right. So with big X, what goes on top? A times C, which is negative 72. What goes on the bottom? B or 14. So I need two factors of 72 that add to 14. Now, since it's a negative 72, that means one of our numbers has to be negative. So one of them has to be negative. So let's just list some factors of 72. Can someone name me one set? So 1 and 72, there's 4 and 18. What else? 6 and 12. What else? 2 and 36. 9 and 8. So 8 and 9. And there's one more. It's divisible by 3. What's the number that is divisible by 3 by? 3 and what? 3 and what? 19. No, it's not 19.
No. Just 3 times minus 24.
It's 24, yeah. 3 and 24. That's right. All right. So, out of all of this set of factors, if I made one of them negative and added it to its corresponding pair, what set would work? 4 and 18. All right. So, if we use 4 and 18, which one has to be negative to give us positive 14? The 4. So, I have negative 4 and 18. And then I'm going to do a quick box method or reverse box. So I get x squared, negative 72. And I replace the 14x with my two new factors. So 18x and negative 4x. Now, since we have x squared in the top right corner, it's very easy. What's the only two factors for x squared? X and x. And again, since they're both the exact same thing, it doesn't matter the placement. So x times what gives us 18x? Positive 18. X times what gives you negative 4x? Negative 4. So my two factors are x plus 18 times x minus 4 is equal to 0. And then our last step for solving anyway is we set both factors equal to 0 and solve. So we make our two mini equations and we're going to solve them. So if I subtract 18 to both sides for the first one, I get x is equal to negative 18. Add 4 to both sides. For the other one, x is equal to 4. So which one's my throw out? Negative 18. So 18 goes away. My x value is 4. So this is the value that they increased by. So they increased by 4 units. Now, that's not my answer because what did the problem ask me to find? Find the dimensions of the new rectangle. So what do I need to do with that 4? How? Right. You okay, Cheyenne? So I'm going to take this 4, plug it in for both x's. So the width would equal 4 plus 6, which is 10. And the length would equal 4 plus 8, which is 12. Thus, our width is equal to 10 units, and our length is equal to 12 units. Now, just to check ourselves with its area, is 10 times 12 in fact 120? Yes, it is. So we did have the correct side lengths. All right, any questions on finding area with quadratics? All right, so here's what we're going to do. You're going to go ahead and don't move yet. You're going to go ahead and take your 5-minute break. After that, you're going to work on your delta math for this unit. If you finish that, there is packet work. It's pages, oh Lord, I always forget this. It's pages 12 through 15, I believe. Now, be warned with the packet work, it is a mix of 8.4a and 8.4b, which we're learning tomorrow. So if it says anything about consecutive integers, just skip it, wait till after tomorrow if you do your packet work. If you finish everything, I do have a short extra credit assignment that involves this if you want to do that as well. All right. And if you, huh? Yes, but remember with Starbucks mode, you can't use your phone. You got to use your Chromebooks. So you can, Apple Music's unblocked, YouTube's unblocked, and if you know what Scratch is, that's unblocked too. Spotify is not. All right, but you got to use your Chromebooks. You can't use your phones anymore because I've been told you can't. So
What if like we use them and then whenever they say like why would you let them do that and then we take the money?
I already had that happen. So
Like on purpose or like on accident?
no, I've been called into the